Okay, Assalamualaikum and good morning. How are you today? Right. Today we'll proceed with the concept of limiting reactant. Okay, I'm referring to the past question given in your booklet. Yeah, you can refer to question number 1C. Yeah, so let's have a look at the question, and maybe this can help you understand the concept of limiting reactant. Okay, now read the question. It says that nitrogen monoxide reacts with oxygen to form nitrogen dioxide. Yeah. So this is the equation. In an experiment, 0.886 mole of nitrogen monoxide reacts with 0.503 mole of oxygen to produce nitrogen dioxide. All right. Now, it says determine the limiting reactant. Okay, what do we do? Yeah. Number one, okay, refer to the notes. Make sure the equation is balanced. Yeah, make sure the equation is balanced. So in this case, the equation is perfectly balanced as you can see here. Okay. And what you do is you start with either one of the given reactants. The thing is, these values, 0.886 and 0.503 mole, is not the amount for complete reaction. Maybe one is in excess. So this is what we want to determine now. Okay, number one, you have to be clear of the information that you have. Okay, for example, here we have N of nitrogen monoxide. So I'm going to write it here. N2. This is, sorry, N of NO. This is the value given to you. Yeah, given is 0.886 mole. As for oxygen, the given number of mole, okay, given, yeah, so we have to be very careful and clear of what the information are. I mean, which and which, yeah. Okay, so we have NO2, which equals to 0.503 mole. This is also the given value, right? Refer to step number 2. Start with either one of the given reactants. So in this case, maybe I would like to start with NO. If I start with NO, that means I'm going to calculate the amount of oxygen needed. Yeah? Okay, we'll see. Okay, now, from the equation, 2 moles of nitrogen monoxide, NO, reacts with or needs 1 mole of oxygen. But in this case, we only have 0.886 mole of nitrogen monoxide, and therefore we can calculate the number of mole of oxygen needed. If you calculate, okay, your X here, N of NO2 will be 0.886 times 1 over 2. Yeah, mole of nitrogen. So this is, we have learned this before. Yeah, that means the value will be 0.443. Yeah, mole of, oh sorry, this is not NO2. Okay, please excuse me. This is just oxygen. Yeah, oxygen. So this is 0.443 mole of oxygen. Right. This is the value of oxygen needed if we have 0.886 mole of nitrogen monoxide. So what do we do now? Okay, what do we do now? We are going to compare. Compare the number of mole of oxygen given with the number of mole of oxygen needed. Given value was 0.503 mole and the needed oxygen value calculated just now was 0.443 mole. Now imagine your father gives you 50 ringgit. Yeah, your father gives you 50 ringgit. But you only need 44 ringgit. So do we have enough or do you have money in excess? Correct. Your father gives you 50 ringgit but you only need 44. That means you have 6 ringgits in balance. Right? So duit is in excess. Yeah? So given value is more than the value needed. Therefore, we can conclude that oxygen is in excess. If oxygen is in excess, that means we automatically know that the other reactant is the limiting reactant, which is NO. You have to write all this explanation, yeah? It is very important. Reactant, sorry. Right? Okay, so now let's proceed with part B. You want to determine the amount of product formed. Okay, let's have a look at the equation again. We have 2NO gas plus O2 gas and 2NO2 gas as the product. Now go back to the definition of limiting reactant. Limiting reactant is the substance that is completely consumed in the reaction. Habis digunakan and limits the amount of product formed. We have oxygen in excess but NO is not enough. So the amount of product formed will depend on the amount of NO. Whatever calculation regarding product after this will depend or must be related to the amount of NO. Right. So we have from the